Have you ever wanted to send DTMF codes but didn't want to spend your time punching them in on the keyboard or on your handheld? You wanted to do it programmatically on something like a Raspberry Pi? Well, stick with me and I'll show you how you can do it on this episode of KX8U Ham Shack. So why would you want to send DTMF tones in the first place? There are a lot of uses, most of which are control functions. And in my case, I want to control when announcements are broadcast from my local repeater. And I don't want to have to manually start this announcement cycle each week, but I would rather automate it. I can remotely start the announcement cycle using DTMF tones, and your imagination can lead to other remote control applications. I will be using Direwolf. You may be familiar with it. It's an open source project and is a modern software replacement for the old 1980s style TNC built with special hardware. Direwolf is an acronym meaning Decoded Information from Radio Emissions for Windows or Linux fans. One of its many capabilities is to encode and decode DTMF tones. We will disable most of the functionality in Direwolf for this particular project. But keep in mind, if you choose to incorporate this concept of sending DTMF tones into one of your projects, you don't have to disable all of Direwolf like I'm doing. In my demonstration, I will only use the transmit DTMF between two radios and not on the same frequency used to control my repeater, as it's the wrong time for the net. So let's take a quick look at my hardware setup. I had a Raspberry Pi 2B laying around that wasn't being used, so I thought I could use it for this project. You could use just about any model Raspberry Pi, however, as the overhead is very low. I only have this Pi currently connected to the network so that I was able to install Jason's KX4 ACK's Build-A-Pi project and to aid in doing this recording. I will not be showing that part of the process, as Jason has done a fantastic job walking everyone through the Build-A-Pi project install. I have linked to his video below and in the description. You will not need to leave it connected to the network once you have everything configured and set up. Would also like to give a big shout out to Jason for his Build-A-Pi project. Thank you. I'm also using a Sabrent USB audio card, which you see here. It's connected via the USB port. And it's connected to the radio with a BTECH APRS V01 cable that you see here. Sorry, it's upside down on the writing. The radio I'm using is a TIDRADIO, which is a BaoFeng style radio, and you can interface this virtually to any handheld, or even many mobile receivers, provided you have the correct cabling. Links to all the hardware, though, that I'm showing here, I will have in the description below. Now, I'm not using a keying program that can be driven out of Direwolf, though that is possible. I'm not doing that with this project. I do have this radio set up using Vox, just because it was simpler and made getting this configuration going much quicker. But Direwolf can be used to output on the Raspberry Pi to key the radio physically. I will be using a second radio as you see here, just to listen to the DTMF tones being transmitted. So for this demonstration that I do today, that's how you'll know that it was working. Now let's take a little look at the software configuration that I used on the Raspberry Pi. All right, let's take a look at the software configuration. I've already previously installed the Build-A-Pi project, and you'll notice on the right-hand side of the screen that Conky is running. I installed Conky only to be able to monitor whether Direwolf is running or is stopped. And we also have Direwolf installed. Those were the only two packages installed with the Build-A-Pi. Now, beyond that install, you do have to configure the Direwolf comp file. And I've written a couple of scripts, a DTMF start and a DTMF stop script that makes automating the whole process a little simpler. And we're going to walk through each of those files. So you can use Nano to edit each of these files, but since I've already edited what I need for today, we're just going to use the cat command to just to read and display those text files. So the first one is the direwolf.conf. Now, as you notice, if you've ever looked at the direwolf.conf that comes just after the install, I've deleted almost everything out of that configuration file. None of it's needed for this particular project. You would only need to ensure that these 5 lines exist if you decide to incorporate this into some other configuration build where you've got other things going on with your Direwolf install. But since this particular project is only using this one function and it's going to be dedicated to it, I've stripped everything else out of this comp file. So let's walk through each of these lines because it makes it fairly simple. The first line defines the sound card. As you remember when I showed you the hardware, I'm using a USB sound card, and that particular sound card is defined by this A device statement. If you were using some other type of sound card other than a USB, for instance, if you have a sound hat, there may be a slightly different configuration that you would need to be able to drive that. And I'm not going to address all the differences. You'll have to investigate those differences yourself if you choose to use something different from what I've got. The channel, you do need to enable that for channel 0. And you also need to put your call sign in. So don't use my call sign. The modem, you do need to install the modem because that's how the beacon commands are being generated, or the DTMF tones are being generated, is through this modem. And then the C beacon statement is actually the key to sending out the DTMF codes. So you have a C beacon statement with a destination equal to DTMF, and then the info line incorporates the actual tones or codes that you're going to be transmitting. So let's take a little closer look at this C beacon statement. So the destination, which is this dest equals, is set to DTMF -3 or -3. The 3 indicates how many characters or how many tones per second are being played. So in my case, we'll play 3 per second. So this whole statement gets executed in about 2 seconds time. The info is what's being transmitted out. So, and if you look close at what I just showed a moment ago in the config file versus what I have here on the screen, here I'm only showing one pound sign, and the 4 6s are the code necessary for my particular repeater to play a recording. But here I'm only showing one pound sign. It's because I actually need that pound sign to be included with the 4 characters. As I mentioned earlier, I'm using Vox to key the radio, and so I send out a second hash symbol that is there long enough to cause the radio to key, and then these other 5 characters are heard as they're transmitted. If this type of configuration isn't acceptable for your radio or for your particular use case, you may want to investigate using the hardline key as opposed to Vox in order to key the radio, then send the statements. All right, so let's move on to the DTMF start and DTMF stop script files that I've included in my configuration. So the first is the DTMF start script, and these are just typical bash scripts, and it's a very simple line where I'm directly calling Direwolf, and this just starts up Direwolf. There's nothing more complicated than that. Again, there's a Direwolf script that comes included, and it does a whole bunch of other checks that are just not necessary for this particular use case. And the second script that I've written is a DTMF stop script. And again, it's a bash command, and the KillAll statement will stop whatever application that we define here. And in this case, I'm defining Direwolf. So it will kill Direwolf or stop Direwolf and turn it off. So we've defined how Direwolf's going to work, and we have the ability to stop and start it with a single statement. Now, I didn't necessarily need these start and stop scripts, but I found that by having them, I'm able to also execute this manually and not use the automation, and not have to go back and remember all the commands and get the path correct every time I type it. I could just run the script and making testing a lot simpler. Okay, so now that we've covered that configuration, let's move on to how we automate. And I automate this with a command called Cron tab. If you're not familiar with Linux and the Linux operating system, Cron tab is a built-in system scheduler, and we're going to use that scheduler to run those 2 script files at specific times. So let's take a look at how I've got Cron tab configured right now. And we're actually going to make a change to this configuration momentarily, and you'll be able to see how it is executed. So the first line that's there, the GPS Maidenhead for Conky, is not needed for this particular build. And if you notice over on Conky, the grid square, it says there's some error. The reason for that is I'm not using a GPS in this build. There's no need for a GPS. I could remove those two statements, but I've left them there if I choose to add a GPS at a future date. The only two lines that are really needed are the bottom two. And so let's take a look and understand how they're, what they're actually doing. So you'll note the DTMF start and stop script and the path to where I have those located. You may or may not put them in the same place. However, I recommend if you put them in the same location, it makes it easy to find. So it's just in my home directory under the Pi folder. So what makes this work are these first several elements that you see over here. There's 5 elements prior to the script. This first element, in this case, is a 59, is the minute that it executes. The next element is the hour which it executes. If there's a star, that means that element's ignored. So the next two elements are actually ignored. But just for reference, they indicate the day of the month and the month of the year, respectively. The last element is the day of the week that it executes on. In my case, I execute this on Tuesday. So cron tab calculates time. Sunday is equal to 0, Monday is equal to 1, Tuesday is equal to 2, and so forth, all the way to Saturday. So if you remember that Sunday starts at 0 and not 1, you'll get it on the right day. So this script will execute or run my start script at 5:59 a.m. every Tuesday. The next line, you'll note it runs the stop script at 18:45, which is 6:45 p.m. every Tuesday. So I run this script for about half the day, a little more than 12 hours, 45 minutes more than 12 hours, in fact. And the reason that I don't start this at 6 a.m., but I start at 5:59, is because the first minute after the script executes, it takes a minute before the DTMF tones begin to be transmitted. So I wanted to be able to time it so the first message goes out at 6 a.m. All right. So that is pretty much all of the configuration. And I think now we'll move to a quick demonstration. And I think the way I'm going to do the demonstration is I'm going to do it in 2 parts. I'm going to show it to you first on the computer, and then I'll change focus and we'll take a look at how it looks over on the radios as it's transmitted. So in this first step, if you notice, actually right now my Direwolf is running. So to start this demonstration off, I'm going to go ahead and manually execute the stop script, and I will do that. And if you noticed over on the far right hand side, Direwolf is now red. So I've stopped Direwolf, and it is no longer going to be transmitting. To run the start script, you notice the Direwolf became active. So this is what will happen on the computer as it executes. I am going to start another window here and run the stop script again. So that's how to execute. So what we're going to do as far as demo is I am going to make a change to the Cron tab so that you're able to see it actually execute. So I'm gonna make a change where I'm gonna actually copy these lines, and you won't need these added lines in the future. Only needing them for this demonstration. And what I'm going to do is I'm actually going to change the time. In fact, I don't even care about the hour on either of those. And in fact, for now, for this demonstration, I don't care about the day of the week either. I'm only going to concern myself with the minutes. And so if we take a look over here at the clock, you'll note it's the minute right now is 14. So I am going to start this at 15, and we are going to stop because it takes 1 minute for the DTMF tones to begin to generate. I'm going to stop this at 17. And we will exit and save that. And just to show you, let's take a quick look at the Cron tab. And you'll note that I've added those 2 lines. And in 1 minute, this will begin, or not even 1 minute, in about right there, if you notice that Direwolf began and turned active. So Direwolf is now running. And I have my second radio that I don't have on screen at the moment. And I will so you see this radio, this is the one that is receiving. The one I have over on the desk over there is the one that'll be transmitting. So as the clock counts down, we have about 15 seconds, and you'll hear the tones come through on this radio. So we'll just give it a couple more seconds. And so that has transmitted, and now let's go back to the desktop, and you'll note the second part of the Cron tab will execute in about another 30 seconds. So I'll talk to you for a moment. And as we get to the top of this next minute, the stop script will execute, and what we're looking for is that this Direwolf will once again turn red as it shuts off. So this will happen in just another 10 seconds or so. And there we have now executed the second part of the Cron tab, and Direwolf has exited and terminated. So that is how you can send DTMF codes using Direwolf, and I hope you've enjoyed this demonstration. I've had a lot of fun doing this project, and it's been a little challenging. This YouTube channel is fairly new for me, and it's taken me some time to figure out how to get all the videos put together so that it looks fairly decent. And I hope you're enjoying them, and I hope that you learned something from this. And again, I want to give a huge shout out to Jason KM4ACK for his tremendous work on the Build a Pi project. If I had to do all the install work that he did, I would find this a lot more difficult, and I wouldn't be as far along in the project as I am today. So thank you, Jason. And that's all there is at KX8U's Ham Shack. And until next time, thanks for watching.